Environmental Science, Chapter 18, Municipal Solid Waste and Hazardous Waste. The majority of waste is produced in developed countries like the U.S. In the United States, each person produces 4.3 pounds of municipal solid waste each day. With proper recycling and composting, this can be reduced to 2 pounds or less. Municipal solid waste is the trash put out in the garbage collector or taken to the dump. In 2009, the United States produced 243 million tons of MSW, which is 4% less than the previous year. The Resource Conservation and Recovery Act, or RCRA, of 1976 is a legislation governing the handling and disposal of solid waste in the United States. Solid wastes include liquids or gases that are or can be stored in containers. The result of RCRA was codification of rules for handling solid and hazardous waste in Title 40 of the Code of Federal Regulations, or CFR. RCRA outlines processes for correct handling of waste, which is different than CERCLA, the Comprehensive Environmental Response Compensation and Liability Act, also known as Superfund, which legislates cleanup of contaminated properties. Historic generation and recovery of waste. Trends in waste disposal in the U.S. show that solid waste generation has gone up steadily per person over the last 60 years, but the amount of actually disposed of in landfills per person has gone down slightly due to energy cogeneration and recycling. The population has more than doubled in that time, so solid waste disposal is still a major issue in the U.S. Several terms are used to describe waste: trash, garbage, refuse, rubbish. Some of this waste is more hazardous than others. Waste is not a characteristic part of nature or normal ecosystem processes. Only humans discard waste that cannot be readily recycled and used by other parts of the biosphere. It's helpful to examine the breakdown of waste, and for municipal solid waste, it's mostly paper products. After paper, second are yard waste that are easily composted, then food, plastics, and metals. In the second part or right-hand side of this figure, you can see what is being discarded, and by weight. Packaging and containers are the largest component of MSW. Even with composting, the U.S. solid waste stream is still 25% food scraps and yard waste. Though most of human history, waste were disposed of through a dilute and disperse strategy. The result is that waste has become widespread and in forms that the earth cannot absorb. Since the beginning of the 20th century, waste management is focused on concentration and containment in landfills. And recently, sustainable waste management involving resource recovery has become a preferred alternative, in addition to limiting waste at the source. In the 12th century, humans have dealt with solid waste in 3 basic ways: burning the waste, which essentially converts it to gas and injects most of it into the atmosphere; storing the waste in dumps, impoundments, and recently sanitary landfills; and disposal by injection or burial deep in the ground in rock cavities. Several approaches have been taken to burning waste. There's incineration for volume reduction. There are resource recovery facilities, or refuse-derived fuel facilities, and mass burn incinerators are both included. There are some problems with incineration, including ash disposal and the generation of hazardous materials. Specifically, heavy metals like mercury, cadmium, and chromium are dispersed during incineration and can cause problems in the food chain and in people. And then there are organic compounds like dioxin and related furans. Dioxins caused from burning things in the presence of chlorine salts or chlorides in other materials, specifically plastics like PVC. Dioxins are a group of chemically related compounds that are persistent in environmental pollutants. Burning waste at low temperatures with these components produces toxic dioxin compounds, and since the 1990s, waste incineration has reduced the level of dioxin emissions to near zero, but so-called backyard burning of fossil waste still produces these carcinogens. Dioxins are found throughout the world in the environment, and they accumulate in the food chain, mainly in the fatty tissue of animals. More than 90% of human exposure is through food, mainly meat and dairy products, fish and shellfish. Many national authorities have programs in place to monitor the food supply. Dioxins are highly toxic and can cause reproductive and developmental problems, damage the immune system, and interfere with hormones, as well as cause cancer. Due to the omnipresence of dioxins, all people have background exposure, which is not expected to affect human health. However, due to the highly toxic potential, efforts need to be undertaken to reduce the current background exposure. Prevention or reduction of human exposure is best done via source-directed measures, in other words, strict control of industrial processes to reduce formation of dioxins, including incineration of waste. Also, incineration is the most costly form of waste disposal. Dumps and landfills. Open dumps, or the first approach to waste concentration, are still a common form of waste disposal, though they create a variety of environmental problems, and they happen to be illegal. Dumps and landfills used to be located in swamp areas and wetlands, which were thought of as useless land. The hazards of open dumping can include the release of toxics and heavy metals into the air and water, the increased presence of disease vectors such as rodents and insects, and physical hazards such as hypodermic needles, poisonous gas, and/or piercing objects. The Resource Conservation and Recovery Act, or RCRA, now prohibits open dumping of solid wastes. Sanitary landfills are closed dumps which need to control possible effluents. The two major effluents are leachate and methane. Water percolating through landfills produces leachate, which may contain undesirable or toxic chemicals. Modern sanitary landfills are constructed to prevent leachate contamination of groundwater, or surface waters. To do this, the bottom of the landfill is lined with impermeable layers, and the leachate is collected and treated before being released into the environment. Factors affecting the composition of landfill leachate include the material the landfill is made of. Is it biodegradable or non-biodegradable? Is it soluble or insoluble, organic or inorganic? Toxic, non-toxic. Landfill conditions also contribute. The pH, temperature, degree of ongoing decomposition, moisture content, climate, and the landfill age all affect the leachate. Also, you can have different characteristics of entering water, such as pH, temperature, and the amount. And soil characteristics under the landfill also play a role. Permeability, depth, and thickness of geological strata and mineral content all affect the leachate from a landfill. Production of methane is caused by bacteria in a landfill when they break down trash in the absence of oxygen or do anaerobic respiration. Because the landfill is airtight, this is a very common occurrence. So this byproduct of anaerobic breakdown of organics is landfill gas, which contains approximately 50% methane and 50% carbon dioxide, with small amounts of nitrogen and oxygen. This presents a hazard because the methane can explode or burn, not to mention that methane is a powerful greenhouse gas. This cutaway model of a modern sanitary landfill shows how the dump is now engineered to collect both leachate and gas from the landfill. Often the gas is burned off, but sometimes it is used to produce electricity to defray the cost of the landfill. The leachate must be treated before water can be returned to the ground. The major difficulty in siting sanitary landfills is the not-in-my-backyard syndrome, or NIMBY, but they can sometimes be converted to parks, golf courses, and other useful facilities after they're closed. The average size of landfills has increased, but the overall number of landfills has decreased over time. Various types of industrial and hazardous waste have been disposed of by injecting them into deep wells drilled in the Earth's crust. Concerns about deep well injection include potential contamination of groundwater, earthquake generation, loss of future use of some aquifers, and adequate monitoring once the waste is in the ground. Some garbage can produce revenue. Often poorer communities will attract garbage from other areas as a way to generate jobs and revenue. This strategy can be detrimental to the community in terms of health hazards and long-term costs versus short-term gains. Here's a picture of a woman taking the lead-based solder from circuit boards and other computers that are sent to China for recycling. Exposure to these fumes is detrimental to her health. So let's review this section. How many pounds of waste are produced per person in the US per day? How much MSW? What is the Resource Conservation and Recovery Act? What does it govern? What is municipal solid waste? What's in it? How much is composted? How much is burned and landfilled? What are dilute and disperse, concentration and containment, and resource recovery? What do they have to do with each other and the history of solid waste disposal? What are the approaches that have been taken to burning waste? Why is dioxin an issue? What are other issues with burning? What is an open dump versus a sanitary landfill? And how are landfills engineered today to prevent harm? And why is poverty a solid waste issue?